Hello friends, welcome back to this video. In this video, I want to help you understand this subtopic called oxides. Now, an oxide, from the definition that can be seen on the screen here, is a chemical substance that contains oxygen and at least one other element. So an oxide by definition is a binary compound of oxygen atom, but it should be bonded to another element, either a metal or a non-metal, and that can qualify it to be called an oxide. Now we can see clearly here that we have a visual illustration of this oxide. We have water, where you have a non-metal hydrogen bonding to oxygen here. Then we can also see that we have sodium on the other end here bonded to oxygen, which is also an oxide. So hence this statement, the oxygen can be attached to a metal or a non-metal. Now, what are the types of these oxides? So we basically have four types of oxides. The first one that we talk about is called an acidic oxide. From the word acidic oxide, you expect that this type of oxide will have some acidic properties, right? And so you can define it as an oxide that can react with water to form an acid, or with a base to form a salt. The best example of these acidic oxides are usually non-metals, but we are not saying all non-metal oxides are qualified to be acidic oxides. For example, these are the acidic oxides from the non-metals, which is carbon dioxide. Now, looking at an equation of how it would look when it is dissolved in water, because we've said it can dissolve in water and produce an acid. In this case, if we dissolve carbon dioxide in water, what we are getting is uh, an acid called carbonic acid, yes, which is H2CO3. So this is how an equation can be shown of how it can react with water and produce an acid. Aside from that, we have sulfur dioxide. Sulfur dioxide can react with water as well to produce sulfuric acid, H2SO4, according to this equation. Now I want you to pause this video and be able to try out this equation, because we've established to say these acidic oxides can react with water, and they can also react with what? Bases, to form what? A salt and water. So what I want you to try out is to write an equation of how this nitrogen dioxide will have NO2 dioxide. It means there are two oxygen atoms there. So it's another example of an acidic oxide. You can see that it comes from a non-metal nitrogen and also oxygen, because this is an oxide. Now, I want you to take this note, very important. This will comprise a non-metal and oxygen, as we already said. Now let's move on to the second type of oxide, which is called basic oxide. A basic oxide is the opposite of an acidic oxide, because it has got qualities of a base. And acidic oxides also react with acids to give a salt and water. More like they are bases and undergoing neutralization reactions with acids. The very basic example is magnesium oxide. When this magnesium oxide reacts with an acid, which is a hydrochloric acid, produces magnesium chloride and water. So it's acting as a base, or this is more like a neutralization reaction in this case. So usually basic oxides come from metals. I think 90% of them, 90% of the questions you'll see having a metal and an oxide will be a basic oxide. So I also want you to pause this video and try out this too. Try to react calcium oxide, which is a basic oxide, with an acid like sulfuric acid, and give me the equation. And also you can try out iron oxide. Let's move on to what are called neutral oxides. Neutral oxides, from the word neutral, are neither acidic nor basic. So they do not have properties of acids, neither do they have properties of bases. They are just neutral. And these are oxides of some non-metals. We've established that usually non-metals will form acidic oxides, but it's not all non-metals. Some can form neutral oxides. The very basic example is carbon monoxide. So carbon dioxide forms an acidic oxide, but carbon monoxide forms a neutral oxide. Apart from that, we have nitrous oxide, water itself, and nitrogen monoxide. So there we had nitrogen dioxide when we're looking at acidic oxide. So I want you to keep these in mind and don't forget them. The last type of oxide we have is called amphoteric oxide. The word amphoteric means these are oxides that have got both properties of acids and bases. That means that if they are reacting with an acid, they act as a base, and if they are reacting with a base, they act as an acid. It's more like they undergo neutralization reaction whether they act with a base or an acid. And these oxides are uh, as we've established, they exhibit both properties of acids and bases and usually come from metals. The very common examples is aluminium oxide, which is the ore from which aluminium is extracted from, zinc oxide, lead oxide, and also tin oxide. So now, let us see an equation of how it would look when these oxides react with an acid or a base, because we've established that they'll undergo neutralization reactions because they can act as an acid while reacting with a base and a base while reacting with an acid. So the first example is this. Aluminium oxide reacts with hydrochloric acid. In this case, it is acting as a base because it is reacting with an acid. So you expect to produce a salt and water only, as can be produced from a basic neutralization reaction. So this aluminium oxide here reacted with hydrochloric acid and formed aluminium chloride and water, which are the products usually when you're looking at a neutralization reaction. That's a salt and water. Then finally, we have each reacting with the base, which will produce the same results as salt and water. So here, aluminium oxide reacted with sodium hydroxide, and then it produced sodium aluminium hydroxide, which is a salt. So basically, that is about oxides, and yeah. So we shall meet in the next video where we shall look at how exam questions are set on this topic. Thank you.